Hello everyone, welcome to Unit 4.4, Pascal's Principle. In this lesson, we will study Pascal's Principle, an important concept in fluid mechanics. This principle explains how pressure behaves in a confined fluid and forms the basis of many hydraulic systems used in engineering applications. Have you ever wondered how a car can be lifted so easily in a workshop using a hydraulic lift? The car is very heavy, yet with just a small push of a lever or pedal, it rises smoothly into the air. How is a small force able to lift such a large weight? The answer lies in Pascal's principle, which explains how pressure is transmitted in a confined fluid. Pascal's principle states that when pressure is applied to a confined fluid, the pressure is transmitted equally in all directions throughout the fluid. This means that any change in pressure at one point in the fluid will be experienced at every other point. Pascal's principle is widely used in engineering, including hydraulic lifts in workshops, vehicle braking systems, aircraft control systems, robots and construction cranes. These systems rely on efficient force transmission through fluids. One practical application of Pascal's principle is the hydraulic lift. A hydraulic lift consists of two pistons connected by a fluid-filled pipe, a small piston with area A1 and a large piston with area A2. When a force is applied to the small piston, pressure is created in the fluid. Pressure is defined as force acting per unit area. Mathematically, pressure is given by the equation P equals F divided by A, where P is pressure, F is force, and A is area. To understand the mechanism and analyze the forces in a hydraulic lift, an external force, F1 is applied to a small piston with cross-sectional area, A1 producing a pressure P1, where P1 equals F1 divided by A1. The increase in pressure created at the small piston is transmitted uniformly throughout the confined liquid and acts on the bottom of the large piston with area A2. The pressure exerted on the large piston is P2, given by P2 equals F2 divided by A2. According to Pascal's principle, the pressure produced at the small piston is transmitted uniformly to the large piston. This means pressure at small piston, P1 equals pressure at large piston, P2. Using the pressure equation P equals F divided by A, we can write F1 divided by A1 equals F2 divided by A2. Let us now look at an example to apply Pascal's principle. In a hydraulic lift, the diameter of the small piston is 3.0 centimeters. The diameter of the large piston is 50.0 centimeters. A force of 250 newtons is applied to the small piston. We want to calculate the force supported by the large piston and the increase in pressure in the fluid. First, we calculate the cross-sectional areas of both pistons using A equals pi d squared divided by 4. Then, applying Pascal's equation, F2 equals F1 divided by A1 times A2. This allows us to determine the output force acting on the large piston. The increase in pressure caused by the applied force is calculated using P equals F1 divided by A1. Since pressure is transmitted equally, this same pressure acts on the large piston as well. Pascal's principle is very important in engineering and construction because it explains how a small force can be used to produce a much larger force through hydraulic systems. This principle allows heavy loads such as vehicles, construction equipment, and structural components to be lifted, moved, and controlled safely and efficiently. By understanding Pascal's principle, engineers and technicians can design and operate hydraulic systems that make construction work easier, safer, and more economical.